Welcome to Facts for Real videos. To make the hunt for life beyond our planet more methodical and targeted, scientists created the Earth Similarity Index. It compares the likeness of a planet or moon to Earth based on numerous parameters such as temperature. The influence of atmospheric pressure on habitability. It goes from 0.0 to 1, with 0.8 and 1 suggesting that a planet is similar to Earth in every way that technological developments have permitted us to discover in recent years. A slew of exoplanets and moons with striking parallels to Earth have been discovered. One of them was named in 2019. BT Garden. This is a super-Earth orbiting an M-type star at a distance of 0.0252 Australian dollars every 4.9 days. The T Garden star is one of our solar system's nearest neighbors, located around 12.4 light-years distant. The red dwarf is 10 times smaller than our Sun and has a temperature of approximately 2,700 degrees Celsius. It can still give sufficient heat to its two worlds. The two exoplanets are similar to our solar system's inner planets and are just slightly more massive than Earth. Both are located in the habitable zone, where liquid water can exist. But T Garden B appears to be much more promising, which is why T Garden B has been assigned an ESI score of 0.95. It's the closest planet to Earth discovered. Thus far, there is a 60% chance that the exoplanet has a temperature surface environment with temperatures ranging from 0 to 50 degrees Celsius. Its atmosphere is akin to that of Earth. The surface temperature would most likely be approximately 28 degrees Celsius. T Garden C, on the other hand, is farther from its star, with a 0.68 ESI score and a 3% possibility of having a heated surface temperature if this world's atmosphere is more comparable to that of Mars, with predicted temperatures of roughly -47 degrees Celsius. The researchers are unsure what the two planets' atmospheres are. Yet, T Gardens B and C are tidally locked to their star, and a thin atmosphere might disperse heat and cold. Scientists believe that atmospheres with densities ranging from 1 to 17 times that of Earth's might support the presence of liquid water on the surface. There is, however, a planetary system. It provides some of the best candidates for extraterrestrial life, as well as the discovery of its most promising candidates. A new candidate has been announced. There are at least 4 planets in the Cly 700 planetary system, 2 of which are in the star's habitable zone. The most promising are the TOI 700E and TOI 700D, both of which are rocky and have comparable features. A large number of people to Earth. TOI 700E has a 28-day orbital period and is 95% the size of Earth, whereas TOI 700D has a 37-day orbital period and is 105% the size of Earth. The TOI 700 system, the size of Earth, has been around for more than 1.5 billion years. More than enough time has passed for biological activity to take hold and turn the thin zone, where the planet's surface meets its atmosphere, into a thriving biosphere. If the TOI 700E and 700D had an atmosphere, they would be substantially warmer than the average temperature on Earth. In terms of habitability, this could be a game changer. Scientists believe that there may be additional planets beyond TOI 700D, and if we ever uncover life forms on any of these worlds, we hope that they are similar to those found on Earth. But similar life forms on other worlds are potentially plausible. Evolution, like gravity, is seen as a universal law of nature. As a result of the process known as evolutionary convergence, where unrelated species can evolve comparable adaptations to similar environmental difficulties, the principles of evolution discovered on Earth can be applied to other planets. The beginning of life on every alien planet must be basic, and there must be many of them. It may have stayed that way. But that could only have happened if some of these worlds developed complicated forms of life. Flight, which developed numerous times on Earth through the creation of wings in an environment filled with fluid like water, can either float if they're lighter than the fluid or use wings to fly aerodynamically and generate lift, for example. Bat wings, bird wings, and insect wings all perform the same purpose. Yet, if two exoplanets have identical parameters such as temperature, atmospheric pressure, and access to water, they may have developed independently of each other. Life might emerge on both planets and evolve in similar ways to adapt to their conditions. Furthermore, the presence of similar conditions on exoplanets may lead to the creation of similar life on Earth, for example, is based on carbon, and it is feasible. If the conditions on those worlds are similar to those on Earth, life on exoplanets might likewise be based on carbon. As a result, whether T-Garden B, T-Garden C, or Toy 700E support life, there's a good chance it might be carbon-based and, to some extent, resemble life on Earth. Nonetheless, it is conceivable that life in the cosmos may take on forms that differ greatly from what we know and comprehend, and it is critical to keep an open mind to the prospect of discovering life that is unlike anything we have ever seen, even on our planet. Extremophile organisms can survive and thrive in conditions that would be harmful to ordinary kinds of life. These life forms can serve as examples or models for potential odd life forms that may exist on other distant planets. Thus far, the search for extraterrestrial life has primarily concentrated on Earth-like planets. But what if we shifted our focus and looked for something else, a form of life as? We have no idea. It may be a world with strange life types, may have a distinct and diversified combination of planetary properties that distinguishes it from more traditional planets. These qualities may be essential for extremophile survival. Severe temperatures, high quantities of radiation, or high atmospheric pressure are examples. Only a few years ago, astronomers identified the Haitian planet, a new type of exoplanet. These planets are diametrically opposed to Earth. Nonetheless, it may be capable of supporting life. The Haitian planets are hot ocean worlds with hydrogen-rich atmospheres that allow for a larger habitable zone than Earth. Scientists are convinced that the discovery could lead to the discovery of signs of life outside our solar system within. Ocean worlds might be up to 2.6 times larger than Earth in the coming years, with atmospheric pressures reaching around 200 degrees Celsius. Nonetheless, similar to Earth's oceans, the oceanic conditions might support microbial life. These planets also offer a variety of habitats, such as gloomy Haitian worlds with potentially habitable circumstances only on their night sides, and freezing icy worlds with less radiation from their stars. The surface pressure on such a planet would be comparable to that of the Earth's ocean floor. Where there is still life, this implies that life may theoretically thrive in a dense atmosphere on a high-ocean world. What's more, biomarkers are easier to detect in the atmospheres of such planets due to their larger size and higher temperatures than those of rocky exoplanets. Furthermore, a significant portion of the known exoplanet population, which is approaching 5,300, consists of planets that meet the criteria to be classified as Haitian. The world is known as K218b, and it was discovered in 2015. The planet is one of hundreds discovered by NASA's Kepler spacecraft. K218b is a spacecraft in the constellation Leo that is 124 light-years away from us. It's a small Neptune that orbits a faint red dwarf, according to experts, and planets like K218b could support life in some situations, because they may include biomarker chemicals such as methyl chloride and dimethyl sulfite living forms. A prominent seam because hydrogen is the primary component of biochemistry, the planet would most likely be based on it. This would imply a planet's environment. Creatures would have a fundamentally different structure than carbon-based living forms. There's even a chance they're completely new to us, and have a completely different appearance and structure than anything we've seen previously. We wouldn't be able to recognize life as living entities based on hydrogen biochemistry. Astronomers are anxiously anticipating the ability to collect spectroscopic studies of high-ocean planets as soon as possible. They are studying a number of high-Fun-like planets, which are relatively close to us, ranging from 35 to 150 light-years away, and the James Webb Space Telescope is already capable of studying their atmospheres. It appears that we are in for a series of mind-boggling discoveries. And how can we determine from our point of view that Earth is the best place for life, and that it plainly supports human existence? Yet we've had plenty of time to adjust to our surroundings. What if there is another planet in the cosmos with even better circumstances for life? This concept of a highly livable world has already been investigated. Super livable worlds, according to the scientific community, would be older, somewhat larger, slightly warmer, and perhaps more humid than Earth. They would also orbit around stars that are older than our Sun and have longer lifespans. Our star is anticipated to survive roughly 10 billion years, while complex life on Earth took about 4 billion years to form. Some stars can survive for a longer period of time than that, allowing for more time for life to evolve. So how can we locate these worlds? Looking for planets orbiting K-stars or orange-red dwarfs, which are cooler and less bright than Sun-like stars, is one approach. Yet, their lifespan range from 20 to 70 billion years. Comparable to life on Earth on a planet circling. A star like this would have more time to grow and adapt. A planet's optimal age would be between 5 and 8 billion years old. Yet it couldn't be any older since it would eventually lose its internal geothermal heat and protecting geomagnetic fields. A super livable world would have a size that is roughly 10% larger than Earth and would have greater land area suitable for life. Such an exoplanet would be 1.5 times as massive as Earth and would have a longer lasting heat source from radioactive decay in its innards and higher gravity to keep its atmosphere, and because warmer and wetter locations, like as tropical rainforests on Earth, have a greater diversity of life. A super livable planet would also require a mean surface temperature that is around 5 degrees Celsius higher. Scientists appear to have worked out that our home planet is bigger than we thought. Out a formula for the perfect planet. Is it even possible that such a world exists? Approximately 24 candidates for such exoplanets have already been found by researchers. In the near future, one of our telescopes may come across a planet that would be ideal for humans. The hunt for extraterrestrial life forms and a perfect new home for humanity continues. We may never find out what is beyond the stars. However, it is exhilarating to consider the possibilities. What kind of planet would you choose to live in? Please leave a remark and please let us know, and don't forget to like and subscribe to the channel. Thank you for allowing us to explore the wonders of the cosmos. Thanks for watching.